Okay, lads. I hope you can see what I have up here today. See if I can zone in a bit in it. Now that might be better. Hopefully you can see it on my screen. So what we're looking at today is sets, okay? And oh God, will that work? Yeah, I think you should be able to see that. Okay, so today we're working on sets. If you just want to read that first of all, and then I'll begin going through it with you. Right, so lads, write down a number that is in A intersection B intersection C. This means, N means common. Do you remember when we used to do that? So if it's an N, I used to say to you, common. Right, so you have the N there and the N there. What's common to all three? So if I do it for A, if I extend A, right, so what I could say is, well, okay, A equals sure going on forever. B equals etc. Okay. C equals going on forever. Okay, it says write down a number that is in common to A intersection B intersection C. A number, so it's not a definite one here. One thing I can see straight away, I stopped because I noticed that we're getting 12s. Look, 12 is a number that's all in common. So once it's common to all three, I just write in here 12. Okay, the next thing it says is explain why C is a subset of A. Subset means that C is if it's a subset, C is part of the set A. It doesn't mean, let's say, for example, C has all the elements. Well, all the elements that are in C are part of A. Will I write that down? Okay, so all the elements are numbers that I hate that word, but anyway, that's how it is. Are numbers that are in C are also part of A. Now it's very important to notice though, lads, that A could have other numbers that are not in C. So like A is not a subset of C, C is a subset of A. So let's just have a look, explain why. Well, C is a set of multiples 4, 8, 12, 16 and all of that. Well, have a look. C contains 4, A contains 4. We have 8, we have 12, we have 16. If I continue on here, 16. So explain why. All the elements are numbers that are in A are in C are also part of A. As you can see from what I underlined in the green part there. Now, I think this is an exam question that came up fairly recently now, and I think what they're saying the next part would have been, well, will you fill in the Venn diagram, the sets for it that comes with it? Well, okay, that's simple. So, because A intersection B intersection C. Think to yourself, lads, what part of the set diagram in front of you overlaps for all three circles? Can you point to it before I put this in? Yeah, exactly. So that's 12. Pardon me. That should be better than that. That's 12. Okay, so 12 is all three. Okay, then I'm aware that A is 2, 4. Okay, it's the multiples of 2. So 2, 4. But hold on a second. Do you see the way C has 4? We have to, so A and C have 4 in common. Because A and C have 4 in common, I'm going to put 4 in here. Because that's the part of the circle where A and C have in common. 2 I'm going to leave here, okay? Because 2 is not part of A, B or C. 4 is done. 6, you can continue. You see, look, you know the way I continued with them. But if you look at the question says 2, 4. So really when it comes to filling in the set, we just had to fill it in for 2, 4, 3, 6, 4, 8. So again, we're going to fill in 3 here, and we're 6. Is 6 in common to anything? Yes, it is. Look, 6 is in common to B and it is to A. So you have to think to yourself, where do A and B overlap? Only here. Okay, that's good. And so let's just check. We're supposed to do 2, 4, 3, 6, 4, 8. 2, 4, 3, 6. And we have 4 in 2, yeah, and then we have, and just put it in 8. And 8 then, I suppose, if we look at the last one, is going to be in, 8 is in common. I'm going to just do it in whatever, let's say this colour. 8 is in common to A and 8 is in common to C. So I can put it in here. So I can see 8 is another one. Then I have nothing for B and C. And I have nothing for C only. So I'm just putting in an X there. Okay, because I just don't know what they are. Okay. Oh, here's the question. Part C. Is it because C is a subset of A? There are 2 regions in the Venn diagram that have no elements. Okay, I just put it in there. Write an X in each of these 2 regions. So I've just done it, look. They're the 2 regions that where the X is to be placed, okay? Right. And then finally we have part D. If you want to read there of D first of all. Okay, and you can see, lads, I've actually answered it, haven't I? In each of these 5 regions in the Venn diagram above, write one of the elements in that region. I automatically did it because I just saw the diagram come up. Normally, like, you'd have the part D of the question above this and then telling you to fill it in. It's unusual the way it was posed that year, in my opinion, but we have it all filled in. So that's that one done. Right, lads, so the next question we have, if you want to read a part A, they're looking for the factors of 12 and they're asking us to list the first 6 of them. Well, the factors of 12 are the numbers that will multiply to give you 12. So we're saying 1 12 is 12. 2 by 6 is 12. 3 by 4 is 12. Yeah, and then obviously 4. 6 by 2 is 12. And I said 1 by 12, didn't I? Okay, there you go. That's the first part. The sets P and S are as follows. P is a set of all prime numbers. Now remember, prime numbers are numbers that only have themselves and 1 as, like say if you say 1 by 2 is 2, as factors. 1 by 5 is 5. 1 by 11 is 11. Like 12 wouldn't be a prime number, for example, because it's got factors. So if it only's got itself and 1 as a factor, that's a prime number. S is a set of all square numbers. So 1 squared, 2 squared, 3 squared, that kind of thing. Okay, now what they're asking as far as write each of the factors of 12 from part A. So they say these are the factors again, just so I want to label this for you so it makes it easier. These are the factors of 12. These are the prime circle there. And then we're saying, the S is the square numbers. Now they're asking me to work on the list of, I'll just write it down here for you. They want me to work on the list above. So we had 1, 2, 3, 4, 6, 12. Well, 1 is a square, lads, but it's also a factor of 12. So I'm going to put 1 right here. 2 is a prime number, but it's also a factor of 12. So I'll put it here. 3 is a prime number, but it's also a factor of 12. So I'll put it right here. 4 is a factor of 12. It's not prime and you can square it. So I'm going to put 4 in where it overlaps for the factors of 12 and the square. Then 6, it's a factor of 12. It's not prime, and you're. Oh yeah, just say there. So right, we're going to say we're looking at 6. Just note on this, right? I'm just going to push this slide. Like, first of all, 6 goes in here, but I want to explain why it goes in here. Some people might be saying, but hold on a second, miss. Can't you not go like 6 squared equals 36? Be careful now. Yeah, 6 multiplied by 6 gives you 36. 36 is a square number. But there isn't, if you take 6 alone, there's not 2 numbers that are identical, whole numbers that you can multiply together to give you 6. So that's why the 6 is in there. It's not a square. So just to say to you there, in case you're wondering about that one. Sometimes it catches people out. And then 12 again, like, oh, I know 144, that's a square number, 12 multiplied by 12. But there's no one number that's identical. If you multiply it by itself, it'll give you 12. So we'll say 12 here. And it's definitely not a square or prime number either. And let's just check then. Is that all of them? I think it is. Yeah, so that's that part done. Okay, and now we're going to look at the final one for today. Just get it set up.